Hello and welcome to the introduction where I'm talking about my BlinkingReminder program now, which is the sources at GitHub followed in the link of this video. Basically, the idea of the program was to tackle the idea of computer vision syndrome. Basically, we as computer scientists spend a lot of time looking at the computer and not resalvinating our eyes. We also might spend a lot of time looking at a particular place on the screen and not focusing. So what I did was I came up with a program that was like a real-time eye tracking application that classified whether that uses some computer vision basic techniques and some machine learning techniques to classify open and closed eyes in order to help computer scientists better in the future. And now the two main technologies that I use is for the face detection. Once a face has been detected, then this face detection is then cropped, and then the eye is then found from the cropped eye image, and then this is just to reduce computational expensiveness instead of processing the whole image. And now the way that I've done the facial detection uses something called a Viola-Jones Haar cascade feature. And as you can see here, for example, this top feature here where you've got the black on the top and the white on the bottom, when you apply it over this face here, it gives us the idea that the eyes of the eyes are going to be darker than for example the underneath the eyes. And then next to here, this feature could represent the fact that the bridge of the nose is a lot lighter than the eyes of the face, the surrounding eyes. And from all of these Haar features, we can construct multiples to up to even 160,000 of these. And then use these across lots of images of positive faces, lots of images of negative faces. And then what we do is we use something called AdaBoost, which is a machine learning classifier, which basically takes the best subset of these features that can still predict whether there is a face or not in the image. And it does this by basically, so you've got all these weak classifiers, these hard features, and then the idea is that we use AdaBoost to construct a stronger classifier in order to predict whether or not there is a face. And now the exact same situation for face detection can be applied to eye detection because of the nature of the problem. So the face detection uses a Haar cascade pre-trained by OpenCV computer vision program, open source, and then once the face has been detected, similarly from the eye, and then we result in what we get here is the cropped eye image. And now what I do here is to reduce the complexity, because this is a grayscale image and really I want to be dealing with binary values to reduce the complexity. So what I did was I did something called an adaptive threshold Gaussian, which basically takes into consideration pixel intensities based on a Gaussian window all the way around it. And it comes up with an adaptive threshold, and this is very, very good because for example, if lighting changes, you still end up with some of the rough output. And as you can see here, this bottom is an adaptive threshold Gaussian of the lower eye, of the closed eye, and this is one of an open eye. So this is what the computer is really basically seeing. And as we can see here, that these two images are extremely different. And once I use some information theory, which is a part of machine learning, just to analyze, just to classify data points, I actually found that the problem of classification of the eye being open was linearly separable. That means that we can draw a fine line in between in between whether the eye is open or closed, literally just by a simple summation of pixel intensities around the eyebrow here. For example, here you can see that because the eye is open, there is a lot of black areas around this, I'll check it out, paintbrush, around this area here, for example. in this area here. But compared to here, we can't. So it's basically a simple summation of pixel intensity values can actually tell whether the eye is open or closed, very linearly separable. I do plan to make it more complex by adding in the future some form of convolutional neural network where the task might not be as linearly separable as possible, given more training data, more examples once I've tested out the program more. But that's basically how the program works in itself. Other than that, it's just a JavaFX GUI with a thread that basically just detects the face, then from the face detects the eye, then from the eye calculates this adaptive Gaussian C, and then calculates a summation of pixels, and then tells you whether the eye is basically open or closed or not. And that's basically how it works. And then hopefully the next bit of the program will show you how it's working. Hello and welcome to the visualization section of the report. This is basically where I'm going to show you the program running itself. I'm going to press run now, and hopefully it should detect my face and eye and then start off the process. Which it has. And notice how it says total blinks is on 0 at the moment. That's because for every single 10 milliseconds the program's been running as now, it's been classifying my eye as being open. However, if I was to make a blink, such as this blink here, it's now detected that I've made that blink. I blink again, blink again, blink again, and it's detecting all these blinks. And also, sorry, I blinked again there. For example, if I move my face left and to the right, it's not actually taking up as many blinks as possible. It's only blinking when I actually do blink. For example, I'll blink there again, and if you're watching my eyes and the counter, when I'm blinking, it is working very, very well. And basically, sometimes if you are about 4-5 feet away from the camera, for example, I'll demonstrate here. It starts to lose your face round about here. So I mean, it still works. It still picks up some of the blinks. But I mean, really, the idea is that you're supposed to be situated about this far away from the camera. Notice how at the moment the blink counter isn't going up, but I can move my face left, I can move myself right, I can start partially occluding my face in places, and it's knowing that I'm not blinking, for example. But then when I do blink, it will pick it up. And it basically just shows how robust this program is to occlusion.